Okay, so for this problem, you guys said 12. So let's take a look and see if that is correct. Spoiler alert, it is. But, all right, so how did we get 12? Because a few people didn't come up with 12. So again, this is like our piece of rope, right? And if I cut it right here, I now made a 5-foot long piece of rope and a 7-foot piece long of rope. So if I put these two ends back together, then I would end up with 5 plus 7, which would give me the whole thing, which is 12. It's just about putting the pieces back together. Okay, so let's take a look at the next one. Find NP if N is between M and P, and MN equals 2x plus 3, and P equals 4x plus 7, and MP, the whole thing, equals 5x plus 23. All right, now I will give you guys a few minutes. I know there's quite a bit of algebra in there to do. So we will take a few minutes on this. All right, so we have answers that are kind of all over the place. So I'm going to lock your screen so you can't change your answers. Ha ha ha. And we're going to do the problem. So this works the same way it has been working. This piece plus this piece equals this piece. So we're going to do the math on this. So this piece is 2x plus 3. All right, now I'm going to add on the next piece is 4x plus 7. All right, and those two things, when we add them, we get the whole thing. We know that the whole thing is equal to 5x plus 23. All right, so now I'm going to combine like terms because I have a whole bunch of stuff over here. So I have 2x plus 4x. That's going to give me 6x. And remember, I'm going to add those things together because they are on the same side of the equation. And then I have 3 plus 7, and that's going to give me 10. All right, now I need to get my x's to one side, so I'm going to move this one. So we end up with 1x, or just x. You don't need to put the 1 in front. Equals 23. Then subtract 10. And so x equals 13. Now, that's not the whole story. The problem asked you to find NP. So we look, and I see NP is here, and it's this piece right here. So what I can do is I can plug this in for that x. So 4 times 13 plus 7. 4 times 13 is 52 plus 7. That's going to equal 59. I feel like something went wrong somewhere. Okay, so let me see here, because I sometimes mess things up. Let's take a look. If I plug 13 in here, I get 2 times 13 plus 3. So that's going to equal 29, which would mean the whole thing would have to equal 88. Yeah, 88. So let's see, if I plug in 13 there, plus 23, that's 65 plus 23. So that's going to equal 88. So yeah, we just were really far off as a class. But that's okay. That's how you do that. And it's okay if it's not coming easy. We're going to keep looking at problems that are like this. We're just adding another piece today. And there's going to be a lot of stuff throughout the entire year where you're going to use algebra to solve based on the relationships of things. That's sort of what geometry is about. It's about taking those shapes and working with them. All right, so today's new concept, new word is midpoint. So we have C to E, E to D. We have our nice E in the middle. A point can be considered a midpoint of a line segment if it is exactly halfway between the two endpoints. So this is exactly halfway between these two things. It splits it exactly in half. All right, because E is exactly in the middle of line segment CD, we know that the distance from C to E equals the distance from E to D. So let's think about this. Say you had a piece of rope and it was 10 feet long and you bent the rope in half like this. You had like a loop. All right, the two legs of that rope, the two things that are coming down are about the same length, right? And that's just a piece of rope. Rope is not going to be as exact as math, like theoretical math type problems are going to be. So here would be our rope. If I cut it exactly in the middle, I would end up, if I had a 10-foot rope, with two pieces that are 5 feet long. It's a really easy idea to wrap your head around. It's a little harder to use it with some of these figures. So let's take a look and see what this looks like. So we know N is the midpoint of line segment LP. Ln equals 2x plus 3, and Pn equals x plus 7. Find LP. So this one might feel like we don't have enough information because we only know this piece and this piece. We don't know the whole thing. But we do know enough to solve this problem. Okay? We know it's the midpoint. So we also know that this piece equals this piece. So we can set up our equation. 2x plus 3 equals the x plus 7. Right? And then we do our math. So 2x plus 3 equals x plus 7. Subtract the x plus 3 equals 7. Subtract the 3, and now you can find that x equals 4. And now that we know that x equals 4, we could figure out by plugging stuff in what these different pieces are, including LP. LP is going to be adding these two things together. So you could write it out like that. You could find your like terms, then plug a 4 in and find out that the whole thing is 22. You could also just solve for each of these pieces. If we plug the 4 in here, you could have 2 times 4 plus 3, right? So you get 8 plus 3, and that's 11. Well, what do you notice? This piece ends up being half of what we know the whole thing is. You would also know if this piece is 11 and these two pieces are equal, that this piece would have to be 11. And then you could also say to yourself, well, now I know that this piece plus this piece equals the whole thing. That's just line segment addition. That doesn't even involve midpoint. And you could get to 22. You could also take one of these halves and multiply by 2. There's a lot of different ways, and this is true for a lot of things in geometry, to get to the end that are completely valid. Like I said, you could just set up your equation and solve for just that one piece. A lot of students would find it easier to just plug 4 in here and figure out that this piece is 11, so this piece has to be 11, and then I add them to get to 22. It's completely dealer's choice on that. Whatever you do that will make you happy. Well, as happy as geometry makes you. And I think that varies from student to student. All right, example number 2. Q is the midpoint of line segment RT. Okay, so RQ, this piece, equals 2x plus 13. QT equals 7x minus 39. And RT, the whole thing, equals 3x plus 5. Find x. So sometimes you receive extraneous information in a problem. You don't need to use it, the RT piece, but you can, not a big deal. So what I mean by that is you can set these two things equal to each other like I did down here, or you could use the regular old line segment addition postulate and say this piece plus this piece equals the whole thing. And you could solve for x, you would get the exact same answer. You could still solve the problem. Just depends how much math work you want to do. So we're going to keep practicing with our midpoint. So 2x plus 16 equals 7x minus 39. So we subtract 7x, we get negative 5x plus 16. Subtract 16, divide by 5. Well, divide by negative 5, and you get x equals 11. So hopefully you can follow the algebra. I don't want to spend a ton of time going over it because you guys know it, I hope. So, right. Anyway, so this question, you guys are going to give it a whirl. B is the midpoint of line segment AC. If AB equals 5x plus 1 and BC equals 7x minus 17, find x. So all you're doing in this problem is solving for x. I'll give you guys a couple minutes to go ahead and give that a whirl. Okay, so let's go over this. We had a variety of different responses. And I will tell you outright that no one got this right. So let's take a look. I don't think so. All right, so we have our two sides. Because it's a midpoint, I know that this piece and this piece are equal. AB is equal to BC. That's what you should be thinking when you see something like midpoint. Like, okay, it splits it in half. Something is equal to something else. So AB is 5x plus 1. And BC is 7x minus 17. All right, so we don't have any like terms on either side, but we do want to get everything together. So we're going to subtract 7x. We get negative 2x plus 1 equals negative 17. We subtract. Somebody was really close to getting this one right. I thought the answer was something different. All right, negative 17 minus 1 is negative 18. I suspect somebody had said that the answer was 8, but you went the other way and you went to negative 16. Because that's really close, and I can totally see where that could have gone wrong. So x would actually equal 9. And if we plug that back in, we would get 5. Nope. That's the next question. So you know what? I'm not going to ruin my own party here. So that's how you get that. We already found. This was supposed to be find AB, and I didn't do that. So we're going to skip that because we're also starting to run low on time. Did I screw this up? No, this is a totally different problem. That's why. All right, well, you got to see that x equals 25. My apologies. I got a little confuzzled because sometimes I do. All right, so find AC. If you had done the algebra on this, you would have found that x equals 25. So I want you to practice that part because that was actually something I wanted to go over anyway. Once you know that, find AC. All right, so that's that part. All right, let's sum up our lesson from today. So a midpoint is a special point on a line segment that is exactly halfway between the two endpoints. When you know that a point is a midpoint, the two pieces of the whole line segment are equal. And you don't need as much information when you know the point is a midpoint. And that should make sense because learning that there's a midpoint gives you actual information. So you might not need as much number or algebraic information as you would because you have that other information. You have information about a relationship between two things. All right, let me know how you guys feel about today's lesson.